All right, looks like we're doing all right with time. I'll try to get you guys in the questions. The last one I had here was basically just a kind of Pythagorean theorem problem. So I did kind of like a basic one, and then I did one that's a little bit, not as nice. So just remember the Pythagorean theorem. Obviously we have the hypotenuse, which is always directly across from 9 degrees, and then we have our two legs. So a lot of times, most students have it memorized as a squared plus b squared equals c squared, where a and b are the legs of the triangle, the angles that are the side lengths that make up the 90 degree, and c is the hypotenuse. So in this case, you can see that we have our two legs, and we just need to figure out our hypotenuse. So we're just going to do 3 squared plus 4 squared equals, c squared. And again, guys, I'm just going off of, they asked me to do Pythagorean theorem, so I'm just making up some problems. However, if you can go over, some problems for me, or at least kind of know where you're getting trouble at, I can help you out a little bit better, or hopefully a little bit better. So now we have 25 equals c squared, and then we're going to introduce the square root. In this case, for these types of problems, negative numbers or negative sides of triangle don't make any sense. So therefore, c is just going to be positive 5. In the next example, we don't have this side, so we're just going to call this x. Now again, you could call it a or b. Doesn't really matter, right? And again, you don't need to use a, b, and c. It's leg squared plus leg squared equals hypotenuse squared. So let's do this. X squared plus 1 squared equals square root of 2 squared. Actually, I didn't really pick one that too bad. So in this case, x squared plus 1 equals the square root of 2 squared, which is just 2. Then subtract 1. X squared equals 1. Square root x equals positive 1. So this actually ends up being a 45, 45, 90 triangle. So either way, there's a lot of different types of complexity with the Pythagorean theorem with radicals and simplifying radicals. I'm not sure if that's what the student wanted or they just wanted some basic stuff. So again, guys, that's why I always ask for some additional, always kind of context when you're doing these. The 3, 4, 5 triangle is also known as a Pythagorean triple. There are many other Pythagorean triples, and those are nice because we don't have to deal with any radicals as a side length. So that's always something helpful.